Hello everyone, my name is Aryan. I am here today to present a small video onto one of the vital services in AWS called VPC. I think VPC is very important, of very big significance, because if you deploy or use AWS, I think you should at least know how a VPC functions so that you exactly can deploy. We'll talk much about that while we cover every nook and corner of this particular service. So without wasting much time, I would start with why. Exactly, why do you need a VPC? This is very important because if you don't know why you're doing it, why you need something, you would not be probably, today we might talk about it, but tomorrow you'll forget it. If you don't know why, what is the significance? So I'll talk more about why, and then we'll more majorly focus on two services or these features, functions, how you deploy or how we use them into production. So the primary thing about a VPC is isolation. When we say isolation, it actually gives you your own isolated environment. Like, people who come from networking background, you can consider that this as equivalent to your broadcast domain. When you terminate that broadcast domain with VLANs, you can consider that a particular VLAN of your own, right? I'll talk much about that in another analogy. I would say, let's take an example of, suppose there is a person who lives in a society, right, or a residential society for that matter. Consider that residential society as my region. Okay, for example, region is the physical presence, right? The physical, or I can say geographical presence of AWS, and that is across the globe. So there are multiple regions. I'll not go more into regions, but coming back to my VPC, consider that the society this person lives in is the region. And um, now, do you think that the person has control over the entire society? If someone lives in a flat in any XYZ society, for that matter, if someone purchases a flat in any XYZ society, do you think that he has control over the entire society? Does he control who can come in, who can go out of that society? I think no, right? No, we cannot, right? And then can this person know or decide who will stay here, who will purchase the unit, or who will be his neighbor? He does not, right? So what VPC does, VPC is the isolated environment. It is indeed not the society as a whole. You can consider that your particular loft in that society can be considered as VPC. You can consider that equal to a VPC. And now I'll talk about that. Why? Because in your particular loft, in your particular flat, you have the isolation. That is kind of a separate unit from the society, but of one individual, right? It has all individuals isolation in there. What I say, individuals isolation, you have kind of boundaries defined. So this is your own space, right? This is what I mean with isolation. And then more security control. Do I control the entire society security? I think no, I don't, right? I cannot. But yes, your own flat, your own house, that unit, yes, you do control security of it. You decide who will come in and who will go out of it, isn't it? But for the entire region, or for that matter that society, I do not. So VPC can be considered as that particular apartment that I or that person in our example lives in, right? Customization, can I customize the entire society? Again, I cannot. Customization in your particular VPC, yes, you can do that. In your flat, yes, you can do it. And what kind of customization do we do? Like IP addresses, right? But in your, if I take that analogy, there are 2 3 4 BHKs that you purchase, right? For example, how many subnets you will have? 2 3 4, I'm sorry, 2 3, right? 4 is not possible. So let's talk about 2 3 uh, subnets that you can decide, right? I'll talk more about that. And again, private networking, indeed, you can talk about those internal networking that you set up. You can decide that. So why VPC? VPC gives you more control. It is your own isolated environment where you have, so you can say within AWS, it is your own particular network. As you had your own data center, it is as equivalent to that. And the more advantages, it's more secure, right? Because in your data center you have particular, one person has access, then somebody who can get in, he has the access to the entire DC, isn't it? But in AWS space, they have different level of securities. I'll not, again, not go much into the security and how these infrastructures are built in cloud. What no, or DC is, we will talk that in some other day, but I coming back to my topic. uh, then second thing is, every VPC, every account, I would say every AWS account, and then you have any region that you have in AWS account, that comes with a default VPC by default. This is, as the name suggests, it's already there. This is the default subnet that they give you. This is the CIDR range of class B private IP. And then you will have those availability zone distributed between two private subnets or public subnets. This is how they configure it. They will configure the router for you. They will configure the IG as well. So we'll talk more about that. But what I'm trying to tell you, this is all that you will get as pre-configured. Why do they do that? Again, for simplicity of use. So somebody who wants to deploy application in here, he doesn't want to get more into the security or the deployment aspect of it, of VPC. So for the purpose of easiness, AWS has set up a default VPC. You just deploy your service and it works for you. Now, when we're talking about more, we talk about subnets. What is a subnet? So subnet, as in AWS space, you can have a public or a private subnet. So it depends, as the public name suggests, that something which can be accessed or which needs public access, right? Which can go outside your private network, right? I hope we understand what is a private and public network. So people who have access to the internet, that is considered a public subnet. Or how do we know that it is this particular person, which is this particular entity called internet gateway. IG actually decides or confirms that whether it's a public or a private subnet. Something which has access, which has connectivity to the IG on that subnet level, it is considered a public subnet. Private, as the name suggests, something which is within your VPC, within your network, doesn't have to go out to the public network, is considered the private subnet. Then third thing is routing, because as we're talking about going out to the network, going out to the public internet, so someone has to route, someone has to tell how to go out or how to go to this particular entity called internet gateway. So this particular routing actually decides how and what packet will go where. IGW, as we were talking about, internet gateway. So this is the gateway, right? As we say, this is the gateway to the internet, to the public internet, right? So any packet that has to go to internet has to go through the IGW, right? It says connects VPC to the internet. Okay. And now second thing is NAT gateway. So suppose I said there is a public subnet, right? And there is a private subnet. So I said this has connectivity to IGW, right? This is my public subnet and has connectivity to IGW. How about this guy now? This is a private subnet. Instances or resources which is local, which are local, they would stay here. But do you think that they would always remain in the internet only? Or when I say remain in internet intranet only, I mean, do you think that they would not need public access? They would not need internet access? Suppose there is a server, suppose there is a Linux server that I am running into my private subnet, but it has you're doing yum update or apt update, whatever you do, right? Depending on the flavor of Linux you have. What I'm trying to say, for patching purpose, it has to go out and get a patch. How would that patch download would happen? So what we are trying to do, we are not giving them direct connectivity to IGW. There is a NAT gateway, which actually the packet goes to NAT gateway routes it to IGW. People who are coming with networking background, they already know how NAT and PAT works. It is quite similar to that. Now route table, as I stated earlier, that route table actually where you write your routes, you actually tell for this particular network where to go. And then suppose this guy from here wanna go to internet, we tell them anything, anything we define with 000, anything which I don't know, send it to IGW. This is how we define your routes in route tables, right? Or for internet internal routing as well. Then, as we said in our why, as we discussed there as well, security is one more thing which is of utmost importance, right? You have deployed your entire infrastructure onto cloud, and your application, your web servers, your databases, everything is working, sitting in the cloud there. So security becomes the utmost important. And for instance level security, when I say instance level security, I mean that particular server, be it Linux or a Windows server for that matter, my bad, So be it a Linux or a Windows server for that matter, this particular server would have one security rule here sitting onto this particular server itself. So it's a server level security called security groups. We can take it with another analogy. Suppose I work with a very small firm. We have like a small office of there are 10 workers work in this office. It's not a big deployment. It's a very small deployment. And now for this, I have but we need security, right? For our office as well, you need a security. So we have a security guard sitting out here. So this can be considered of a small level security, or at lower level, or at a unit level. I mean, so when you are doing unit level security, you can do it on you can consider that NIC. So when I say unit, um, it is actually attached to the NIC of the instance, the server. And why I'm saying small level, or what exactly I want to convey with this is, if you have a small setup, if you have a office of like 10 employees, this person who's a security guard for a small setup, I'm sure if you have 10 people working in an office, you know them in and out, right? You know they come every day, you know them by name. So this guy can be considered like this fellow, and in our language we call it stateful. Why we call it stateful? Because in if anybody want to come into your office, this person checks the list of who is allowed. So you actually, this guy checks who's allowed, right? It's a small office. There are 10 workers. It checks the list. Okay, this person is allowed, right? Is an employee. He's allowed in there. If this person is allowed, he lets him in. But as I said, stateful is this guy remembers who he is allowed in. So if this guy wanna go back again, once he's done, it doesn't check the rule again. I'll say that again. Security groups do not check the outgoing traffic. It only checks inbound traffic, incoming traffic, and we can only allow in there. This is how you define, right? It checks who is allowed. You don't define deny in there, which is not allowed. Anything which is not allowed, that's explicitly denied, right? So this is how your security group works. But the second thing is NACL, right? The other thing is NACL. It's again the same kind of security, but I'll tell you why it's a bigger thing, little bigger thing. Now we're talking about a corporate, a big corporate, like, who has like 2,000 employees, for example. And if not big, very big, small, but it's bigger than this. This is what I want to convey. I don't want to say, I'm not saying 2,000 is a very big count. What I'm trying to say is it's bigger than this small office of 10 people. What I'm trying to convey with that exactly is, if you look at an office where there is a strength of 2,000, usually they have this access card system, right? You have that access card, you have to swipe your access card, and then you get the inside entry, right? So NACL is that access card machine actually. So what it does, when you go in, you swipe your card, then you are allowed, right? And if you go out, does it remember you? That access card machine, does it remember you? It does not, isn't it? We have to swipe the card again, then it lets you out as well. So what I'm trying to say with this analogy, don't get into the verbatim, guys. What I'm trying to convey is, this small office is a security guard is a stateful who remembers. If somebody goes in, it actually remembers that this guy is allowed inside, so it will let you go out without checking the rule. But NACL is that security, or consider that your access card at your office, you have to punch it in and out both time. If you punch it while going in, it will not let you out, right? You will have to swipe the card again. So what I'm trying to say here, you have to configure inbound and outbound rules both, right? So it actually checks both of them. For security groups, you usually configure inbound traffic, whatever you want to allow, and outbound is by default allowed, right? For that particular socket, something which came in, that is allowed outside. But yes, there is an option for configuring outbound SG as well. So in some situation where you don't wanna allow some traffic to outside world, like anything, be it outside world or internet or anything, you can definitely go ahead and configure that outbound rule and deny it there. Now, so this is the one which remembers, called stateful. The one which doesn't remember, like NACL, doesn't remember as a socket connection for something goes in, doesn't let it out by default, that is called stateless. And for inbound and outbound, you have to configure both the rules. And in default security group, the NACL is configured in such a way that it does allow every connectivity. For security group, you do have to configure what you're allowing. Now, there is one more important thing called VPC peering. So what exactly, as the word suggests, VPC peering is peering of VPCs, right? So what I mean, there is a VPC 1, or I can say VPC A in a particular region, and there is one more VPC into another region, for example, right? And you want these VPCs to talk to each other directly. Why do we need that? Why exactly we want that? Do they not communicate? There is a server here, right? There is one server here. Do you think that they would not communicate to each other? Yes, if they're publicly accessible. If they're publicly accessible, this guy can go all the way out to the internet, and from there it can come here as well. If this is a publicly accessible entity, like take example of 11 dot something, 10 is a private range IP. So let's take example of 11 dot something. So yes, this is indeed accessible from outside as well, but what you are losing here is you're sending the traffic all the way out to the internet, and then it's coming. There is security which gets compromised at times if you don't uh, ensure that there is a security measure taken care of in the public network as well, right? There are multiple way where you can do encryption for the data which is going through the internet. The second thing is you pay for it, you pay more for it. So data which is coming from the internet, that gets higher charges, and then again it's coming through the public network, so there is a latency also comes into the picture. So that packet gets all the way through the internet. That is not as good dedicated as good as these dedicated links in AWS they have deployed. So that's the faster internet, the faster links with less latency. So we prefer, and then you're paying less for it. It's within the cloud. So how we do, you can configure VPC peering, and with peering you can send the traffic within the AWS itself using the AWS backbone network, which is secure, which is faster as well. And then there is transitive peering, which is again so if we have VPC A which trusts VPC B, and there is a VPC C as well. So suppose this guy trusts this guy and this guy trusts this guy, but there is no peering between these two. So it says it will not by default trust each other. Like we used to have that mathematical thing earlier, like A is equal to B, B equal to C. So that doesn't mean A equal to C. So we will have to explicitly define that as well. This is transitive peering. There is one more thing, a bigger picture called transit gateways. What are transit gateways? They make it very this thing for you very easy. We have 3 VPC in our example right now, but if you have more than 3 VPCs, if you have a bigger deployment, in that situation you will not do this hub and spoke connectivity for every VPC peering, right? That will make it very complex. So transit gateway actually solves it. So transit gateway is something like a middleman in between, and there is a VPC A, then VPC B, and here we have VPC C and VPC D. So this guy actually terminates these connections, and originate means it does that connectivity for you already. So this is the game, this is the task of transit gateway. It actually does it for you. In bigger deployments, in especially production network, you will see transit gateways deployed very widely, and they're a little higher on the cost, but they make it very easy for you. The deployment gets easy, configuration gets easy, and there are less issues of traffic routing and all. Now, when I'm talking about issues routing, there are things, if you deploy something, that there are possibilities things go wrong as well. So you should know how and where to check from. The first thing, if there is an issue with connectivity, that we suggest verify first. Verify your route table. You check if there is a particular route configured for that traffic that you're trying to send. So check the route table. Check if there is a wildcard entry for anything go out to the internet, or there should be a route available. That's you have to verify. Then you have to ensure what? You have to ensure your security groups are configured to allow that traffic. And as I said, incoming traffic is checked majorly for security groups. So for one socket which is allowed in, that will go out. But there can be a possibility that you have configured outbound rule for some reason, and that outbound rule is still blocking because there is a implicitly you have mentioned that deny this. And then there is NACL that you have to go and check if your NACLs are configured properly. And if you think that you have verified configuration, you have verified your security group and NACL, and still there is a reachability issue, you can go through VPC flow logs. So you have to configure them. By default, they are not enabled, and then you configure them, and then you send those logs to destination. If they're going to CloudWatch, there is a time. I think by default it's 1 month, but I'm not too sure about that. We'll have to, you can refer back to documents and check. What I'm saying that it will only retain those logs for a month, right? And then if so on 31st day, probably that log, the 31st day older log or 30th day older log will get deleted. But if you want to retain them, then you can also push them onto S3. Here you can apply retention policies, and you can, in S3 there are ways where you can retain it for longer time and pay less. Now, uh, so now, just to summarize what all we have covered, what is VPC? And as I said, it's a virtual private network. As the name suggests, it's your own private network in the cloud. Key components, as we have talked about, security, security group and NACLs, and then we spoke about peering, that we talked about transit gateways, and there is one more concept of EIP, elastic IPs. Elastic IPs are static IPs, but which you can retain. It's a static IP which you can retain. So that's an elastic IP in AWS space. And then, production grade designs. Yeah, this is one more important thing, as I was talking about, two network, two subnet or three subnet, right? So for again, taking an analogy for it, suppose you are constructing a house, right? You will have to, if you're constructing for somebody, you will ask the person how many rooms you need. Do you want to make it 2 BHK or 3 BHK for that example? So if what I'm saying, what I'm trying to convey, you have to ask for whom you are building the house, who is going to use it, right? The actual user of it. So suppose you have to deploy an application, and you don't know whether it's a 2 BHK or 3 BHK. In actual terminology, you don't know if it's 2 tier or 3 tier application. It'll be in 2 subnets or 3 subnets. So you will always go and ask the user, the application owner, who is actually who owns the application. They will tell you if it's a 2 tier or 3 tier. If it's 2 tier, you'll deploy it into 2 subnets. If it's 3 tier, you'll put it into 3 subnets. And why do we do that? So that we can isolate them at subnet level. And you remember, those NACLs, they also work on subnet levels. So here you can also define that what traffic can go into what subnet, and then again you have security groups to go more granularly. And then there is IAM as well. IAM also plays a role in here, where you can get more granular into the security aspect of it. If I talk more into this will make it more lengthy. So I would just give you an overview on that. Security best practices, as we have already spoken, NACL, SG, and then IAM is one more thing that you should focus on, consider to make it more stringent security wise. So that's it. I'll give you a quick peek onto how this is there in the production deployment. So this is AWS account where I've logged in. I'm into the Mumbai region, that region that I was talking about. I gave the analogy of our society. So this is the region, and I'm in the VPC right now, and I'm going to create a VPC for you quickly. There are two options. You can go and create VPC only, and then you will create other components gradually, one by one. Or there is one more option now, which is called VPC and more. We'll pick that one. So once you do that, VPC and more, it actually creates those subnets, those endpoints, and all those required resources automatically. And there is this button. It's taking a little time to load, probably because of the speed, but there is this quick button to create, and this user that I'm using is not authorized to create VPC. But if you configure, if you check, that's the way you configure it. If you have the user which has due role or due permissions to create resources, you'll be able to create it. That's it. I would say this is just the overview, right? There are things which I might have taken just names, but this is just to give you an overview. We can talk more about that in detail with those topics when we go on them one by one. Thank you for your time, and That's it. Thank you.